dielectric slab between the plates of a capacitor. Let us first choose one capacitor plate which is empty and there is nothing in between, and you are connecting it to a battery of potential V0, and this capacitor will be now fully charged. And let us assume the charge now on the capacitor is Q0 and the capacitance of this capacitor C0, and the potential across which we are applying is V0. Because we know capacitance value is epsilon naught A by D, that is number one. And what is the electric field that is set up between the plates of the capacitor? Let us call that it is E0. Because we know that electric field is the negative of the potential gradient, and here it is E equal to V0 by D, assuming distance between the plates D. So what all things? So when you connect a capacitor, a parallel plate capacitor, to a potential V0, let's assume that its charge built on the capacitor is Q0 and the capacitance is epsilon naught A by D, and E0 is this. Because Q is equal to CV, so here Q0 is equal to C0 into V0. Now, without disconnecting the battery, what if we insert a dielectric? So, we are not disconnecting it from the battery, we are still keeping the same capacitor and we are still applying V0. Okay, without disconnecting, now you are inserting a dielectric between the plates of the capacitor. Once you insert this dielectric, what all will happen? First, once it is inserted, and now the field will be set up and all those things. The electric field will be set up in this. Here what remains constant is that since you have not disconnected, V0 is constant and the distance between the plates does not change. Hence E0 is equal to new potential by the distance. Since the new potential is V0, E0. So without disconnecting the battery, if you insert, previously also the potential drop across the capacitor V0, now also potential drop V0, and the electric field is V0 by D, now also electric field is V0 by D. These two does not change. But what about the capacitance? Capacitance is epsilon naught A by D. Now it is a dielectric slab of constant K. So new capacitance is equal to K times epsilon naught A by D, assuming the dielectric constant of the capacitor K. Then the new capacitance is K times this, but epsilon naught A by D is C0, so it is K times C0. So without disconnecting battery, if you insert a dielectric constant, capacitance becomes K times C0. And the next one, energy. What is the energy stored in the capacitor? Energy stored in the capacitor. Here previously, what is the energy stored? Energy stored is equal to, we can say, half CV square. Here it is C0 V0 square. Or energy can also be written as Q square by 2C. So that is Q0 square divided by 2C0. Either way, you can write the energy. Okay, now what is the energy after inserting the dielectric? We know that V0 does not change here in this case, but what has changed is capacitance has changed. It is KC0. So here half CV square we are supposed to substitute. Half in C is actually K times C0 and V is still the same. So it is V0 square. So K times half C0 V0 square. So K0 half C0 V0 square is the initial energy stored. So if you insert a dielectric slab without disconnecting battery, energy becomes K times U0, capacitance becomes K times C0, and electric field and voltage remains the constant. What about the charge? Previously charge is C0 V0. Now what is the charge in this? Q is equal to CV, but C has changed. It is K times C naught because C is K times C naught, and V naught is still the same. So C naught V naught is the original charge stored Q naught. So the new charge is equal to K times Q naught. So once a battery connected and dielectric slab insert, charge becomes K times Q naught, energy becomes K times U naught, capacitance becomes K times C naught. Let us try to understand the same. After disconnecting the battery, if you insert a dielectric constant, what will happen? Suppose this is the thing. You have disconnected it from battery. Now you are inserting a dielectric slab of thickness D. Now what will happen? Let's say here what is constant? Here, since this is disconnected from the battery, no additional charge will enter, no additional charge will leave. Hence whatever was the original charge Q naught, the same Q naught will stay. So without disconnecting battery means V naught remains a constant. After disconnecting it, once disconnected, Q naught is constant. Once it is Q naught, let us try to understand the other things here. So new charge is equal to original charge, initial charge. What about the other things? Capacitance. Capacitance is still the same. So dielectric slab inserted, K times epsilon naught A by D. In this case also, capacitance becomes K times C naught. So here charge remains constant, capacitance becomes K times C naught. And what about this thing? We know that this charge Q is equal to CV. So this C and new potential V. And here Q naught is C naught V naught. But C is K times C naught. So K times C naught. V we don't know, equal to C naught V naught. I have just substituted. I know that capacitance becomes K times C naught. But new charge after inserting the dielectric is actually equal to old charge Q naught, because charge does not, no charge is entering or leaving. But Q naught, based on this C naught V naught, Q is actually new capacitance into new potential. I have found the new capacitance, which is Kc naught. Hence the new potential we don't know. Using this, when you cancel, what you are getting new potential is V naught by K. So it's very important to remember. So if battery does not, if you don't disconnect the battery, V is constant. Once disconnected, V becomes V naught by K. Then what about energy stored? Energy stored in the capacitor equal to half CV square. So half. Now the capacitance is K times C naught and the potential is V naught by K whole square. So it is half K C naught V naught square by K square. K and square will be cancelled. So half C naught V naught square by K. So new energy is U by K, which is U naught by K, because half C naught V naught square is U naught, half C naught V naught square is U naught, so it is K. So once battery is disconnected, capacitance still becomes, in both the cases, capacitance still becomes K times C naught. But other than that, electric field same. So charge and energy becomes K times. Here voltage and energy becomes 1 by K times. So these two things you are supposed to remember. So let us say, right, battery connected, battery disconnected. So initial charge Q naught, battery connected, it becomes K times Q naught, battery disconnected, it is still Q naught. And initial potential V naught, battery connected, it is still V naught, and battery disconnected, it is V naught by K. and initial electric field E naught, battery connected still E naught, battery disconnected, it is K times E naught, and sorry, E naught, because electric field is actually V naught, V by actually D. So because V naught is E naught, V is V naught by K, we have found V naught by K, V naught by K divided by D, it is 1 by K times V naught by D, which is equal to E naught. So electric field also becomes E naught by K. So here it is E naught by K. Then we talked about charge, potential, electric field, energy. So energy U naught, battery disconnected, energy is, battery connected, energy is K times U naught, battery disconnected, energy is U naught by K. So these are important things to know about. What happens to charge, what happens to potential, what happens to electric field, what happens to energy.